Welcome to all of you. Today we will study about buffer action. In last video we have studied buffer solutions and types of buffer solutions. And today we will study the buffer action of acidic buffer and basic buffer and applications of buffer solution. Now buffer solution is defined as a solution which resists drastic changes in pH when small amount of strong acid or strong base or water is added to it. And buffer action is a process by which added hydrogen ion or OH ion are removed. That means the effect of added hydrogen ion or OH ion is nullified from the buffer solution so that the pH of the buffer remain constant. That is called as a buffer action. There are two types of buffer solutions, acidic buffer and basic buffer. Acidic buffers are used to maintain the acidic pH, and basic buffers are used to maintain alkaline pH. Now, acidic buffer solution means a solution containing weak acid and its salt with a strong base is called acidic buffer. And pH of acidic buffer solution is less than 7, that is in between 0 to 7. Examples are acetic acid and sodium acetate, or formic acid and its salt with a strong base such as sodium acetate, hydrogen cyanide and potassium cyanide or sodium cyanide, benzoic acid and sodium benzoate, salt of a strong base. So like this, these are examples of acidic buffer solution. Now consider the mechanism of this buffer action of acidic buffer. Now consider here a solution which is composed of a mixture of acetic acid, that is a weak acid, and sodium acetate, which is a salt dissolved in water, forms a mixture. The mixture of these two forms a acidic buffer. Now here acetic acid is a weak acid and sodium acetate is a salt. So acetic acid is weak acid, therefore dissociate to a little extent like this. Acetic acid gives you acetate ion plus hydrogen ion, and here the very few number of acetate ion and hydrogen ions are formed in the solution, and most of the acetic acid molecules remain undissociated. So the concentration of undissociated molecules of acetic acid is more in the solution, and sodium acetate, it is a salt and therefore dissociate completely and gives acetate ion and sodium ion, and as it dissociate completely, the concentration of acetate ion is more in the solution. When a small amount of strong acid is added to this solution, then the added hydrogen ion combines with excess of acetate ion present in the solution, which is a conjugate base of acetic acid, and forms unionized molecules of acetic acid like this. Acetate ion, which are present in a large amount, reacts with added hydrogen ion and forms undissociated molecules of acetic acid, and thus the effect of these added hydrogen ion is nullified, and therefore the pH of the solution remain constant. And this property of a buffer solution is due to presence of this acetate ion, excess of acetate ion, and that is called as a reserve basicity. Like that, when strong base is added to such a solution, then the OH ions, added OH ions, are neutralized by a large concentration of unionized molecules of acetic acid, and the OH ion, added OH ion, reacts with undissociated molecule of acetic acid and form acetate ion and water, and thus the pH of the solution remain constant. And this property of buffer solution is called reserve acidity, and this reserve acidity is due to presence of undissociated molecules of acetic acid. Like that, basic buffer. Basic buffer is a solution which contain what? Weak base and its salt with a strong acid, and pH of basic buffer is greater than 7. For example, ammonium hydroxide and ammonium chloride. Ammonium hydroxide is a weak base and ammonium chloride is a salt of strong acid. Or ammonium hydroxide, ammonium nitrate. Ammonium nitrate is a salt of strong acid, nitric acid, and weak base ammonium hydroxide. Magnesium hydroxide, magnesium sulfate, or copper hydroxide and copper sulfate. Now consider here basic buffer ammonium hydroxide and ammonium chloride dissolved in water, which act as a basic buffer. Here ammonium hydroxide is a weak base, dissociate to a little extent like this. Ammonium hydroxide gives you ammonium ions and OH ion. As it is a weak base, less number of NH4 ions and OH ions are present in the solution, whereas undissociated molecule of ammonium hydroxide is present in a large quantity. But when ammonium chloride is dissolved in it, then ammonium chloride is a salt, dissociate completely and gives you NH4 ions and Cl ions. And as it dissociates completely, number of NH4 ions also present in excess in this buffer solution. So when small quantity or amount of strong acid such as HCl is added to the solution, then hydrogen ions immediately combine with excess of NH4OH, that is undissociated molecules of ammonium hydroxide, and neutralization takes place, and ammonium hydroxide react with hydrogen ion and gives you ammonium ion and water molecule, undissociated molecule of water. And due to this, the pH of the solution remain constant. And the property of this buffer solution is called reserve basicity. And this reserve basicity is due to presence of undissociated molecules of ammonium hydroxide. Now when strong base is added, then the added OH ions reacts with excess of NH4 ions present in the solution like this. Ammonium ion reacts with OH ion and gives ammonium hydroxide in undissociated form. And due to this, pH of the solution remain constant, that is effect of added OH ion is removed or nullified. And this property of buffer solution is called reserve acidity. And this reserve acidity is due to presence of NH4 ions present in a large amount. And due to this, the effect of added OH ion is nullified. So thus acid or base added cannot change the concentration of hydrogen ion or concentration of OH ion, and pH of buffer solution remain unchanged. Dilution also does not have any effect on pH of buffer, and this is because the concentration ratio term in Henderson-Hasselbalch equation remain same, and therefore dilution does not change this ratio. And pH of buffer solution is independent of volume of the solution. And due to presence of reserve acidity or reserve basicity of buffer solution, pH of the solution remain constant. Weak acid or weak base along with its ion, that is cation or anion from salt, reacts with excess of added acid or added base and maintain the pH of the solution constant. And this property is used in many fields such as biological system, or this action of buffer is used. And pH of blood, you know that pH of blood is maintained at 7.36 to 7.42 due to carbonate buffers. that is HCO3 minus plus H2CO3, which is a weak acid. And change in pH by 0.2 unit also can cause the death. Also in agriculture, buffers are used to maintain the pH value of a soil. You know that the pH of a soil is very important, because most of the nutrients are absorbed or available at certain pH value. Here generally in this diagram it is shown that this thickness indicates the availability of the nutrient. So copper and zinc, boron, manganese, iron, these are available when soil is slightly acidic, whereas calcium, magnesium, sulfur, phosphorus, nitrogen, these are available in a slightly basic pH, if the soil has a basic pH. So the effect of soil pH on availability of essential plant elements, greater nutrient availability is indicated by thickened line, whereas narrow lines indicates a decrease in availability. So the soil get buffered due to presence of salts such as carbonates, bicarbonate, phosphate and organic acid, and the choice of the fertilizers depends upon pH of the soil. Also in food preservation, sodium benzoate, sodium citrate are food additives used as a buffer in generally jam and jellies. The addition of sodium citrate to food containing citric acid will create a buffer solution. So to maintain the constant acidity within the food product, pH are essential. Also potassium tartrate is obtained from grape, which is used in wine making as well as in bakery products it is used. Calcium carbonate is also used to maintain the pH during fermentation process, or calcium citrate is used to regulate the acidity in cold drinks. In medicine, penicillin are preserved in buffer solution of sodium citrate, or citric acid is added to milk of magnesia and forms magnesium citrate. Or most of the medicines are prepared in aqueous solution, and these aqueous solutions require a constant pH, and thus medicines are stabilized through the buffers. In dyes or paints, color strength of dyes is related to pH, which is maintained by using different buffer systems, such as monosodium phosphate is commonly used to maintain a low pH for acidic dye. Also in paper industries or printing industries, electroplating industries, buffer pH is required, and this is controlled by the adding the buffer. In analytical chemistry, in qualitative analysis, precipitation of cations of third A group requires basic buffer, that is pH is in between 8 to 10, and it is maintained with a buffer of NH4OH and NH4, adding NH4OH and NH4Cl. So like this, these are what the applications of buffer solutions. Thank you.